Friends, in this video, we have studied the calculation of the time and the energy loss in transient operations. So friends, let's begin. Friends, in calculation of time and energy loss in transient operation, we will study to find out the value of the calculation of time and energy loss. Okay, so first point for the sake of your understanding is to understand the concept why we want to get the value of the time and the energy loss in concern with a transient state only. Because guys, in a day-to-day life in concern with a electrical drive, we are having the two types of state. First step is called as the steady state, and second one type of state is called as transient state. Okay, so second type is called as a transient state. So why we want to get the calculate the value of the time and the energy loss in concern with the transient state? Because in steady state the motor torque is equal to the load torque. So that is the condition which is called as equilibrium condition. So in concern with the steady state, the value of the time is not significance. So we are not considering or not calculating the values of the time and energy loss in concern with the transient state operation. So we are considering the calculation of the time and the energy loss in concern with only transient state. Because in transient state means what? The state of the starting, the state of the braking, the state of the speed change, or the state of the speed reversal. Such conditions are called as a transient operation. So in concern with the starting of your drive, we will require what should be the time to start that particular drive. Then next thing, that what time the drive is said to be a stop. So we want to calculate the time for the braking, and similarly we want to get the value of the means the energy loss and the different values of starting, different values of braking, and different values of speed change and the speed reversal. So such conditions are called as the transient operations of your electrical drive. So guys, will start to calculate the values of the time taken and the energy loss. This is called as the energy dissipation in motor during the transient operation, and that can be evaluated by the solving of the following equation. This equation, which is called as the T, this is the motor torque, which is called as T, is equal to J, that is J is called as the polar moment of inertia with respect to the rate of change of the angular velocity with respect to time, that is called as the angular acceleration, plus TL is called as the load torque, plus the B into value of omega m. What do you mean by T into omega m? This is called as the TV, and TV is called as the viscous friction torque of your motor, and this will be the first equation from which we can get the value of the time taken and the energy dissipation in the transient operation. So when the value of T and TL are constant and proportional to the speed, means the first condition is that when T and TL both are constant, constant means it is the proportional to the speed. So that time it will give you obviously a linear differential equation. So that will give a linear differential equation. So from that we can get the value of the time required for that particular thing. That will be the first thing. The second thing is that when the value of t and tl are neither be constant nor proportional to the speed, means the value of t and tl is neither be the constant nor be the proportional to the speed, basic equation will be nonlinear differential equation, and then this equation is numerically solved by the Runga-Kutta methods. So this equation will be solved by the Runga-Kutta method by the nonlinear differential equation. So this will be the very important thing in concern with the calculation. So guys, theoretically now the transients are calculated by means of the infinite time, which is not so in practice. So basically transients are over in finite time. So in order to get or resolve these anomaly transients, the operation is considered to be over when 95% change in speed has taken place. So now we can understand what will be the concept. So the concept is that, guys, suppose we are taking one of the stability of your electrical system. So this will be the transient state stability. So this transient state stability is look like that. That is a transient state operation. So this will be the value of omega me. This will be the value of the equilibrium speed of your electrical drive. So we are considering is that this will be the lower band of the transient state stability, and it has a different transient state components which has not significant value. So we are considering this the term that is the 0.95, or it will be called as the 95% of the total value of the, means the value of the equilibrium speed. So this will be the treated, why we called it as 95% or 0.95, because of such reasons. Okay, so now we are taking one of the example. So the example is that when the speed changes from the value, that is the value which is called as the omega m1 to the equilibrium speed. Now we can take one of the example for your understanding. So such examples is called as, suppose we are taking one of the example. So this will be the curve which is plotted against omega m versus t. We want to find out the value of the omega m1. This will be considering the equation number omega m1. This will be the first value, that is called as the initial value of the angular speed. Then this will be the equilibrium value of your speed, which is called as omega m e, and this will be the 95% value of the equilibrium speed. Now we called it as omega 2. So for sake of understanding, to calculate the value of the omega m2, because we have the value of the omega m1, that is the initial value of the angular velocity, that is called as omega m1. So we are just finding out the equation of omega m2 is equal to basically omega m1 plus, so we called it as the value that is called as omega m2 is called it as 0.95% or 0.95. Why we getting this value of 95 that we had discussed earlier? So we are getting this term that is 0.95 in bracket. We want to get the value of what, that omega m2. So that is called as, this is the total value of omega me minus we want to get the value of that omega m1. So we will get the actual value of omega m2. So while we are substituting the value of the equilibrium speed with respect to the omega m1, now we are getting the value of the omega m2. and this will be the required expression for the value of the final speed of your transient state. So this will be the equation of omega m2, and this will be resolved by the equation number 2. Okay, so this will be the concept. So next we will start to understand the calculation of the transient state. So for the sake of the calculation of the transient state, first of all we can get the fundamental torque equation. So we know that what do you mean by the fundamental torque equation. The fundamental torque equation is given by, that is T is equal to, basically this value is called as the T is equal to, that is TL plus J into d omega m by dt. So what do we mean by T? This is called as T or Tm. It is called as the motor torque. TL is called as the load torque. J is called as the moment of inertia, and d omega m by dt is called as the angular acceleration of your drive. Okay, so this will be the fundamental torque equation of your electrical drive. So if you want to get the value of the dt, means we want to get the value of the transient time for that particular operation, we can move that the right hand side dt to the left hand side. So we are shifting the dt, that is in left hand side. So dt is equal to, we are getting j into d omega m, j into d omega m. So we are just shifting that dt here. So we will get j into d omega m divided by t omega m minus tl omega m. So what do we mean by t omega m minus tl omega m? Basically t is called as the motor torque, where tm and tl are the functions of the driver speed. So what do you mean by the function of the driver speed? We can get the simple thing. So that is, the simple thing is what? The motor torque and load torque. Basically these are the functions of the drive speed. So that's why in that particular equation the TL value of the omega m and T the value of the omega m, because these are called as the functions of the driver speed. So the time taken for the drive speed to change from the value from the initial speed to the final speed is given by the integrating equation number 3. So for calculation of the value of the t, that is time t, now we are basically integrating this equation by means of the omega m1 to the omega m2. What do we mean by the value of the omega m1? Omega m1 is called as the value of the initial speed, that is the initial speed of your drive. What do we mean by the value of omega m2? That we had earlier calculated, it will be the final transient value of your equilibrium speed. So this will be the called as the omega m2. So for the calculation of the t, now we can integrating this the equation by means of the omega m1 to the omega m2. So we are getting the equation, that is t is equal to j, we are taking it as the common, the integration from the omega m1 to the integration value of the omega m2, then d omega m divided by t in terms of the omega m minus tl in terms of omega m. So what do you mean by t into omega m? It is a motor torque, it is the load torque, which is the function of the speed. Okay, so this will be the required equation to calculate the value of the time of your electrical drive. So this will be the very important equation. This will be the equation number 4. So by this equation number 4 we can get the value of the time of that particular reversal of your motor. So now we can move towards the very important bit, that is called as the fundamental thing that we are getting from the equation number 4. So from equation number 4 we are integrated, and when we are integrating, if we are getting the directly value of the motor torque with respect to the angular speed and the load torque with respect to its speed. So these values are known, then and then we can get the value of t. This will be the first thing. If you don't know the value of the motor torque with respect to your speed, if you don't know the value of the load torque with respect to state, then what will happen? At that time we can get the value of this, the t, by means of the graphical method. So in graphical method, what will happen? In graphical method, we are getting the term, we are getting the basic term, that is the term which is called as the acceleration term. Acceleration term that will be plotted in a y-axis. On in x-axis, we are plotting the value of the speed, that is the, that is omega m, and the other term in the integration, and that term is called as j divided by the functions of the motor torque in terms of speed and the function of the load torque in terms of speed. Okay, so we are getting the value of t by means of what? We are just plotting one characteristics in concern with the speed. So we are getting the value of speed in which omega m1 is the value of the initial speed of your drive. The value of omega me is the value of the equilibrium speed of your drive, and the value of omega m2 is called as the final transient speed value. So from that particular graph we are getting one shaded, means the area, and that the area will denote directly the value of time, that the value which is called as the value of time which will be required to start or to stop or to break the drive in a transient state condition. Okay, so this will be the one of the important thing. Next we will start to get the value of the omega m2. So in the value of the omega m2 is an equilibrium value of speed, that is called as omega me. So it will be the reciprocal of the acceleration. So the reciprocal of acceleration means what? It will be 1 by alpha. So it will be 1 by alpha, means it will be give you the value of the alpha. So consequently the time the evaluated is the way will be the infinite. Why the value of the time is the infinite? Because due to that, in this case the transient can be computed by measuring the area between the speeds, that is omega m1 and omega m1 plus 0.95 in bracket omega m2 minus omega m1. So what do we mean by omega m2 minus omega m2? That is called as omega me, that is called as equivalent value of the speed. So from that particular equation we are getting the value of the final equilibrium speed of your drive. So this will be the very important thing, and by the things of that particular value of omega m1 and omega m2 we can directly get the value of the time required to do the transient state operation. Okay, so this will be the first thing. Then we will find out the value of the energy loss which is called as dissipated in a motor winding during the transient operation, is given by the basic, called it as the Ohm's law, and that is called as the E is function of 0 to t with respect to I square r dt. What do you mean by the t? The t is called as the time of that particular transient state. The I is called as the current flowing through it. R is called as the motor winding resistance with respect to time, that is dt. So this will be the standard equation by means we can get the energy loss or the energy dissipated in a motor by means of the transient state analysis. Okay, so now we can conclude the different two formulas. That is, the first formula is concerned with the calculation of the time of the transient state operation, and the second formula, which is called as the energy loss in transient operation. So the first formula, that is time in transient state operation, is called as T is equal to J, that is polar moment of inertia, integration of omega m1, it is the initial speed with respect to the final value of the equilibrium speed with respect to d omega m divided by motor torque in concern with the function of speed minus the load torque in concern with the function of speed, that is TL into omega m1, that is for the time in transient state operation. And the second equation, which is called as the energy loss in transient operation. So what will be the equation of the energy loss in transient operation? That will be given by E is equal to integration of T into I square R dt. So what will be the value of T? The value of T, we are getting the value of that T from that equation. We have the value of the resistance, we have the value of the current. So simply we can get the value of the energy loss in concern with the transient state operation. So in this way, we have derived the different formulas for the calculation of time and energy loss in transient state operation. Thank you.